do it. What is up, everybody? Happy Wednesday. Thank you all for joining us. We always have a killer audience, amazing people in our community. Welcome to live stream number 113. We are growing up quickly. Very happy to be here. Before we get started, just a couple of reminders, usual stuff. If you're not in our Slack channel, jump in there. If you haven't subscribed to YouTube, do the same thing. Do yourself the favor of subscribing to YouTube right now. Our channel, we've got tons of content. If there's content that we don't have on there that you would like us to get, please let us know and we will definitely organize that. We've got pretty much all of the next 2 months booked with content all the way. Obviously January, we're just about to finish. We've got February, we've got 2 live streams every week, including panels. Next week on Wednesday, where it's not published yet, but we will be having a panel about the business side of Kubernetes. How can open source be leveraged in a business sense to provide real solutions for companies that will be providing additional value to their customers? So we'll be focusing on that next week. Like I said, we got a panel. On February 16th, we'll be having our first local, albeit virtual, meetup that we'll be doing, DoK London. We'll be having a hands-on workshop between Ondat and HashiCorp, followed by a community-based panel with some wonderful DevRel folks. You can expect a lot of content in February. Like I said, we've got at least 2 live streams every week for the entire month of February and also March. We're now starting to add live streams to our calendar in April. And April gets us closer to May. And what's going to be happening in May? I think you should know already, but we will be having our 3rd DoK Day in KubeCon co-located event on May 16th. All right, it's going to be a Monday. It's going to be a fun day Monday. You can check out our CFP. I'm just going to drop that here in the YouTube chat. You can check out our CFP. We are looking for speakers. Very clear indications in the CFP, just so we don't have any misunderstandings. We are not looking for vendor pitches. We are looking for end user experiences, talking about running stateful workloads on Kubernetes, much of which we'll be talking about today with our speaker, but definitely check that out. We are planning on having 2 tracks so we can have even more content, get all that good stuff out there about data on Kubernetes. So definitely check that out as well. That leads us to our speaker of the day and also a very special live stream today because we've got prizes, all right? We've got something for everybody. And then we also will have a little bit of a quiz challenge at the end with a special question. So you can win a copy of Rob, our speaker today, his liveProject. I'll get him to talk a little bit more, but I'm going to drop the link in here for today, the discount code. So you can, if you go to the link that's in here, I'll drop this in here right now. You can get a 35% discount on all Manning publications, on all the products in all formats. For Manning, 35% discount. Just go there. You got the link and you got the promo code as well. But then, like I said, additionally, we'll be dropping a quiz question, both here in the YouTube chat, but you got to answer the question in our Slack channel. All right. So we'll be dropping the question in our Slack channel, and the person who has the correct answer will win a free copy of Rob's liveProject. I've said Rob's name several times, but we haven't brought him on yet. So Rob, you're doing awesome stuff at Rumble. You're also a published author. Who are you? What are we going to be talking about today?
Hey everyone, so thanks for having me. I'm Rob, it's Rob Pacheco, full name there. I have been using Kubernetes since, I don't know, maybe 2015-ish, if I had to guess. I can't do math well, so I'm not gonna say how many years that is. But just some of that time frame, I started mostly early on it. And I've been doing this at a few different companies now. So I've been, started initially at doing this at Black Duck Software, actually, to sort of get them a really great SaaS offering hosting on GKE. And then went through a few other companies. And throughout that time, a lot of it has been really at the intersection of, how does Kubernetes do things really well? And how does that make life easier, harder for the application developer? Actually, so I'm getting ahead of myself here, I suppose.
That's okay. That's okay.
Let me share my screen here.
That's okay. Yeah. Folks, as usual, drop your questions in the chat on YouTube. We'll get to them accordingly. Got a lot of stuff we're going to be covering today. Pay close attention as always. But yeah, Rob, take it away. If you want to share your screen, go for it.
All right. Let's share a screen here. Okay, that didn't work out for me. Let me share and then go to full screen for the. So let me get there. Where's my Zoom window? This is ironic. I use Zoom all the time and I can't find a Zoom share.
Okay, no worries. No worries. Not a problem. And as always, thanks to all the wonderful people who are joining us today from many different parts of the world. We had really, really good numbers in the sign up. So thank you for being engaged and paying attention to our meetup page. You'll see all the other stuff that we got on there as well. So you can sign up for the meetups that we have that are upcoming. But anyway, good to have all of you. So yeah, whenever you're ready, Rob, just go for it and share that screen.
I got some horribly bad news here. I did get a new MacBook not too long ago, and I realized I never actually set up screen sharing for it. So I'm going to have to rejoin the meeting in just a moment.
Not a problem. I will keep everybody busy in the meantime. That's all good.
2 seconds. I'll be right back.
You do your thing. So folks, as usual, really energized about all the things we have going on. I know I already mentioned we got KubeCon, we've got some upcoming live streams. We've also got a really interesting project that if you want to see, get some hands-on experience, we're always talking about this, why run data on Kubernetes? We also want to give people the capacity to be able to get their hands dirty. So if you jump in our Slack and you see the channel called the How to DoK project, you'll see some wonderful folks that are using different technologies. Remember, we're never trying to push one technology over another. So we want to embrace all the different ways that we can run data on Kubernetes. So we got some folks there that are putting the rap lyrics that we get from the raps that I write about our different speakers. We're putting those on a database and then putting them through Argo to get them on Kubernetes. All right, so we can have a real world example. We also got someone from Percona that's stepping up. It's got a killer use of IMDb, the Internet Movie Database. So also going to be incorporating that. We're always open to new ideas. So just remember, our community is a space. It can be a sandbox. You can play around with these technologies, get experience, meet really, really friendly people, and of course, have a good time doing so. So if you're in our Slack channel, definitely check out the How to DoK project. We're always open to new contributors. We've got first-time issues for folks that are just starting out. We have other things for people that might have more experience, that want to take more of a leadership role in a technical sense. So just feel free to check that out because, like I said, it's one of the ongoing things that we have. How are we doing, Rob?
I'm good now. Sorry about that, guys.
It's all good. No worries.
All right, so let me share a screen here,
yeah.
Like I tried to the first time. That's right. So we're there.
Perfect. Looks good.
There. I mean, I already did that, so let's not do that again. And then let's go with some slides here. I don't have a massive amount of slides, but I figured, I don't know, if you just sort of start, it might be good. So, all right. So like I was saying before, you skip here. So I'm Rob. I have liveProject. I am in the process of developing a liveVideo, sort of related to liveProject actually. So that's in the works. And I have been doing a lot of work over the past, I don't know, 5 to 8 years or so, really working at the intersection of how does Kubernetes help the application stay stable and make it simple to deploy and manage, and what impact does that have on developers? Because it definitely does have impact from the perspectives of, how to run it locally. Do you need a full setup? Can you run certain services? And then, as this presentation is about today, what impact does that have on storage? Because in a lot of ways, it does have a surprising impact, especially where you have application developers who are there who aren't familiar with running in large clusters. So let's start off with who this talk is for, right? So I'm really targeting 2 audiences here. Hopefully some of you fall into that category. One is for application developers that are writing services that run on Kubernetes. And the other is for Kubernetes operators that really need to have a hand in guiding the architecture of the application and services to make sure it's going to run well. So that's what it's going for. And today we're going to talk about, obvious question here, but just sort of to make sure everyone's on the same page with me here. What are stateful applications? What am I talking about when I say that? And one really sort of obvious question here is, why run stateful applications in Kubernetes? Or I guess, can you avoid it in a way? And then as you start talking about, these stateful applications, what does Kubernetes provide in terms of storage and persistent storage and any sort of mechanisms there to help us out? And the opposite of that question is, all right, well, if you don't want to do this in Kubernetes, well, what are you left with? If you have to run some of your services in Kubernetes, what do you do with the stateful parts? And then really, hopefully a lot of the bulk of, this presentation is, all right, so you want to run a stateful workload in Kubernetes. How does that actually impact how you design and develop your applications? And so that's what we'll be doing today. And so the first question here all right, what's stateful? Right? Like everything is stateful, right? It's very hard to write something nowadays, or really ever, that's not stateful, right? You have your Amazon shopping carts, you have your banking applications, you have your security scanners, right? You have everything. Every application contains some part of state. I suppose there might be a handful of things in the world that I haven't come across yet that don't, but most things are really stateful. But then, so let's say you have your application and it's comprised of a bunch of services. Maybe it's 2 or 3 services, maybe it's 100 services. So then what distinguishes, what services are stateless and those that are stateful? And so, some key indicators there, does a service need to remember any data? And there can be varying degrees of that, right? It could be that, your shopping cart data needs to persist forever. Or it could be that you have an application that, finds value in caching some data temporarily. So it can be a little more volatile. And the other aspect to that is, how much does the state of that service prevent it or help it to move around a cluster, right? If you have, a massive Kubernetes cluster, maybe you have 100 nodes there, right? That's not super massive, but still it's not small. Can you get to a point where you have, various services that need to go down for some reason and come back up somewhere else? And does that cause any disruption of its data? Data can be stored, simplest thing ever, the file system, which a lot of applications can make use of. Second thing, there's a database. A lot of data gets stored in databases. And then nowadays it's horribly common to use various cloud-based services. And when choosing those, you do have a lot of pros and cons there. So we'll get more into that as we go through this. And so just sort of, very basic level here, how does Kubernetes persist data? Well, so you got a pod, right? And you have some containers, and that may or may not provide any, facilities, but then you have these things called volumes. And a volume is just sort of a primitive in Kubernetes that says, hey, I can store data for you in some way. It doesn't really say how. It's more of just an abstraction to say, I know how to do that. But then when you get into the process of saying, well, I really do want to persist this data for a long term, right? You end up in the case of needing a persistent volume. That's not all kinds of volumes. There's different levels of that, but you have a persistent volume whose intent is to store data forever until you tell it otherwise, or until for some reason it loses it because it was configured not quite the way you've expected. And for a pod computer to actually use one of those, it needs a claim on it. And it turns out that in most ways, this ends up being the problematic part of stateful workloads on Kubernetes. We'll go into that a bit. So some of those are that volumes depend. So one step back there, right? So there are a multitude of ways to come up with a persistent volume, depending on what you're doing it, right? Things like Minikube, right? A very small little local Kubernetes cluster will store data for volume right on the node. And that's not really problematic because in Minikube, you have one node. It can stay there forever and you're good. You don't have any issues trying to move things around. In other types of clusters, that's more problematic. So, previously, I ended up setting up a micro-K8s cluster for one of my staging systems. And micro-K8s is pretty kind of cool, right? It's a really simple way to install Kubernetes on Ubuntu. Other systems too. It really did start for Ubuntu though, and it runs there well. And start off with one node. That was easy. I didn't lose a volume there. You had a host path, and it was great. It worked amazingly. And then my cluster had to grow. And so at that time, right, we were still using, it was called the host path storage class on micro-K8s. And as the different containers moved around the cluster, well, it lost its storage. It couldn't find the right storage. It was on a different host. And so that caused problems. Other problems, which I hit in a number of cases more early on, is that a lot of the volumes that exist, really a lot of the storage drivers that exist, don't support multiple writers, right? It runs in a mode called like read write once. Now, there are some storage systems like Gluster and Ceph a lot of more complicated systems that will support multiple writers. And so a lot of these difficulties, a lot of the choices to be made, and this really comes down to when you're setting up the cluster, when you're choosing what you build as part of this, right, comes into play in, what other facilities do you want to add in, and what storage drivers do you want to support, and the ultimately varying levels of difficulty. And then another issue that you run into is, as you replicate services, unless you're using, a more specialized storage system, these services get their own volumes, and then you sort of have a partitioned or sharded data system. And that can cause more problems if that's not anticipated. So, all right, let's say for some reason, we're like, all right, we can't run this in Kubernetes. It just gets too crazy. Let's do something different. Well, you do have a variety of options there. And so I've used a lot of Amazon examples here, but the same are true of most cloud systems, Google, probably DigitalOcean. I haven't used that too much, but a lot of Google I've used in the past, right? But you have, Amazon RDS, you have Cloud SQL, you have Amazon S3 or Google Cloud Store. In a lot of cases, it's not incredibly uncommon. Say, I want to use a database and I don't want to use a pre-hosted system because that either gets complicated or expensive or any combination of those. So I'm going to go and set up just, a straight up separate VM with Postgres running on it, and I'll connect to that. And then you have other types of hosted Redis and other sorts of things. So there are a variety of options if it ends up being the case that you really just don't want to store state in Kubernetes. They exist. At the same time, there's the question of, well, why do you want to store it in Kubernetes, right? What is the advantage to running a stateful workload in Kubernetes? Also, I thought I should mention it sooner. I'm told my audio was good, but if you ever can't hear me or if I ever fade out there or any problems, just let us know and we'll fix that up.
Sound great. No worries. Sounds good.
Okay. If it happens, let me know.
It's all good.
So back to this, right? So the reason, and this is more speaking personally, right? I can't say this for anyone here, but my reasons, right, for running stateful workloads is that it simplifies a couple of things, right? It entirely simplifies the deployment process. Being able to have a Kubernetes resource to represent your storage and to change it over time and to know it's going to be there in a very declarative way, to me was a very big advantage in that space. In a lot of ways, right, there was also a price advantage to it, right? You're going to pay a lot of money for something like RDS. Now, for some reason, some cases you have to. One of the other reasons, right, outside of complexity, that you may not want to run a stateful workload on Kubernetes is performance, right? A lot of the ways that Kubernetes stores data uses storage drivers that are network-based. Now, I've never really had a problem doing such a thing, but it could be that you just have incredibly high performance needs and you can't find a suitable network driver or a suitable solution to get to that performance and keeping it in Kubernetes. So that's probably one of the bigger reasons not to, if you can't get a setup such that you have good enough performance. But it hasn't been a problem. And really, for me, having the entire setup in declarative Kubernetes, YAML using customize, was one of the main advantages. Now, over time, I do suspect, and there's been various pieces of work on this, that there will be sort of Kubernetes proxy resources for various cloud systems. There were some attempts at that. They sort of got toned down a bit. There are other alternatives to it. I think we'll get there, and that would be a definite benefit. But the other reason to not do it, right, to keep this on Kubernetes is it is infinitely more reproducible in different environments, locally, in different types of, maybe across clouds or across, say, a GKE versus micro-K2. We have different staging systems that aren't all in the same cloud. To have this all done in Kubernetes, to have that level of seamlessness that you can run it anywhere. So really for me, and for those that I've worked with, that ends up being one of the bigger benefits to doing this. You have everything essentially in one spot. So those alternatives, and those are reasons too or not to do it. All right, so now let's actually see something, right? I'm not really too big on slides. So I'm gonna have some, seems to actually we have any questions yet?
No, so far so good. Super well explained, very concrete. And I absolutely loved, we've done this live stream number 113. The way that you just explained your reasons for writing stateful workloads, you can expect that we are going to take that as a quote and we're going to put that video out separately. So anyway, so far so good. Yeah.
Sounds good then. All right. Then let's see, let me exit out of these slides here. Central I got the slides. And I have a little application here. So we're gonna, not the right window. All right, here. So it's a little tiny Go thing. Really the implementation isn't super important. Really all this does, and it's incredibly super simple intentionally. There's really no point in making it complicated here. That's not the point of this. But basically it has a little API that allows you to write data from curl. Because I figured that was the simplest possible thing we could do. How do you get data into a container and then look at it? And so that's all this does. And now to help elaborate on all of this, right? So we have a Docker file. I've already built this locally. Again, super simple. Go builder here, build it up, ends up in container, and you call it a day. So I have 3 different YAML files here. The first one we want to look at though is here. So remember I said that really volumes cause most of your issues in persistent workloads. Entirely true. So this has a deployment, right? All it's really going to do is it's going to run that container. So I've called this container DoK sample, tagged as latest, and it's going to run this command. And that's it. That's what it's going to do. It'll listen on port 8080, and it'll wait for those write requests. Now, in this setup, so actually, I should mention one thing before really going into this, right? There are various levels of storage in Kubernetes, right? The container, to some extent, has its own storage, which will be lost as soon as the container leaves. The pod can also have its own storage. In the most typical way that gets done is by doing this empty volume. And this allows containers within that pod to reference it. Now, just sort of as a side note here, I've used this a lot to allow 2 containers in the same pod to communicate via files. There's a downside to that, right? In having multiple containers in the same pod. It's not something I do commonly, and it's usually a workaround for certain things. But when you do that, right, it really gets you in a position where you need to scale the entire pod if you need more than 1 copy of it, and that can be problematic. But this does work for that. It does let you share storage really easily between 2 containers in the same pod. But so let's say we do this, right? Let's say that, the other advantage here that I didn't mention, but sort of I kind of implied there though, is that I've done this and I've put these containers in the same pod because unlike most other volume types, this does allow 2 containers to write to the same location. And that's really what I was going after there with those containers communicating through that file system, is that both containers can read and write from the same location. And so that's an advantage to this, but it has downsides. So let's take a look at this. So I'm going to pop up my terminal window here. And I am in this directory of these 3 files. And I'm going to apply that first one here. Right, okay. The same thing we just looked at. And now, since this is a demo, it's going to go horribly wrong. I knew that's not horribly wrong. I don't know. I literally just ran this 2 seconds before I got on this call. Not making that up. All right, give me just 2 seconds here.
All good. Yep. Not the first time that the demo gods have decided to be a little bit tricky and providing the opportunity to run it again and see what's going on. It's all good.
I did run this one. Names. Did I run the right thing? That literally makes no sense. Master IP says invalid value. No, I didn't set that. Double check something. Am I really in the right spot here? Here, my service there. This isn't saved. That's fine. That is certainly interesting. While I'm doing that, let me just flip over here just in case this definition is any different. Let's see. Not dynamical. All right. Okay, let's try it again. Okay, that worked. Didn't look any different when I did it the second time, but we're up.
But it worked. It's all good.
Like I said, I figured something would just go horribly wrong here because it has to happen. So let's take a look at what we have here. All right, so we got that's running. And the only volume we have here is that empty volume. So because I'm running in this is all running in Minikube, by the way, though. But since I'm doing that, I haven't set up anything like a metal LB or anything. I'm just going to port forward there quick. And then, like I said, we have this little curl command, and it's going to write something. So we're going to do that. And now we're going to take a look at our container. So let's see what we have there again. And we're going to exec into that. Just take a look at the storage. I feel this is a little simpler and a little more explicit than doing something like a elaborate API to get data back. We'll sort of get down into it. So I skipped over this part, I think, but I set this as the storage location. We mounted that too. And we have a file there. The contents of this is just the host name. If you wouldn't get too complicated there, just put something there. So that's there. We have one file. And if we make another call, we'll have a second file. Now, these are great if you have short-term data you don't care about, like if you want to actually keep cache data, this might be a good place for it. If you want long-term data, this doesn't work out so great, really for two reasons, right? One is, let's say we restart this guy. And so that'll restart. Just give that a second to come back up here. And then we'll get back to that and we'll take a look at what the volume has there. Get this guy out again. We'll go back to the storage location. And we got nothing, right? So that volume is squarely attached to the pod. That pod restarts, get killed, goes away, the storage is gone. And so that's sort of why I opened this with, well, it's great for temporary things. You know, if any data is specific to the pod you want to cache, you want to store, that's a good place for it. If two containers want to communicate, as long as that data is specific to the pod and can die when that pod dies, great place for it. You don't want to store a database volume here. That would not end well. So that's the simplest way to do it, right? You get a lot of advantage to having that pod-based volume, but it does not survive. So let's just delete this namespace again for a second and go to our next one. So what is our next one? And so the next one I have here, right, is same thing, deployment, nothing really different about it, except we attach a persistent volume to it. And now this isn't going to go quite the way that we expect this to go, but that's okay. I'm going to do it anyway. Now you'll notice the access mode here, right, is rewrite once. And this implies, and this is the case for most storage drivers, that only one pod can be writing to at a time. So we're going to take a look at this. And in general, it'll improve our situation. And then I'm going to say one thing about why it's not doing what I really wanted to do, but that'll be fine. So let's run this. We're going to report forward this since that whole thing went down. And we're going to send some more data there. It'll do 2 files this time, just to mix it up a bit. We'll get our pods. And let's go see that we have some data there. So we're here, go to Farrell storage, and we've got 2 files. We can see what's in those. And yes, we have 2 from the same pod. All right, great. So now I'm going to hop out of here for one moment, and I'm going to do the same thing we did last time. Right, I'm going to restart this pod. And we're gonna not write any more data. So we're not calling curl anymore. We're going to compare our pods again. We can see that this just came back up. New pod, and we're going to go there. So let's head in there and see what's in our storage. And now that we're using an actual persistent volume, we still have data there. Okay, so now the part that doesn't do what I wanted to do. So newer versions of Minikube, and it seems MicroK as well. And let me just show you this. I'm going to scale this out to have 2 replicates. Now, in older versions of Minikube and MicroK, and in most other situations, this wouldn't work as you would expect it to. So here we really do have 2 pods up. We scaled it to 2, and we can run a million of these things too. Well, let me master plan. No problems doing it there. I'm just gonna make a few more times just to try to get to all of them. And let's just pick one to go into here. The same one should still be there. So we're gonna come in here. Got a bunch of files. And we can even see here, right, that we have different workers that came in and actually wrote data there. And just take a slight diversion here from what my original plan was. But we can look at the PVCs we have, right? Those are the persistent volume claims. And we only have 1 of them, right? And we see the access mode is still rewrite once, right? You should still only have 1 writer into this, and it's there. And if we describe this, we see that it's bound to 2 different pods there, like 2 entirely separate pods, not saying they're just different pods. And in most cases, outside of what Minikube and MicroK are doing, this would not be allowed. And so part of the problem that we're not seeing here, that we really should be seeing, is that you wouldn't really be able to scale out a deployment. The other thing that we're not seeing here that I was going to try, and it's will seem the same effect, is that trying to restart a deployment bound to a PVC, depending on the storage drivers you're using, it could be problematic because it wants to disconnect first. Otherwise, it would end up in the same situation where you have a PVC trying to be bound by 2 different pods at the same time, and that causes problems. So I was a little bit saddened to see that I could not show you that. I didn't think too far ahead to set up like a GKE cluster to show some of this. Next time I may very well do that, because the newer version of this are, they're sort of taking advantage of the fact that they know it's a local file system. So they know these things are okay and that'll succeed, versus other types of real CSI drivers that would have no part of this. So with that being said, I'm going to once again delete the namespace and show you what really should be happening here in the proper way to handle state in your own application. And then I'll talk about a few other things after that, but let's get through this first quick. We'll delete sample. This does take a second. A little ironic, it's only like one thing there, but it takes a minute. And then to show you where we're going to go next here, we're going to do the stateful set one. Now, this looks almost identical, right? And I guess one other word about this, really the differences between stateful sets and deployments for those who are unfamiliar, right? So a deployment is really the most common thing in Kubernetes, right? Its job is to really deploy and control one or more pods. It'll make sure the pods stay up. It'll make sure it can replicate them. They can scale up and down. It can restart them. And it's the most common thing, especially that I've ever used in Kubernetes. Now, the stateful set is very similar, but its job is also to manage pods. But it has more of an emphasis on state. And so really, the intent is that it handles the association between a pod and its persistent volumes and claims differently. It's also meant specifically for stateful workloads, so that it also intends to have, and I'll show you this in a second too, reliable host names. So now that that's finished deleting, let's just run this one. And I do want to point out before we do this, right, just keep in mind that the format of these names and how they changed every time we either scaled out or we restarted. So we'll apply this. That will be up in just a second. I'm going to go back and report forward this. And really from a pure storage and persistent volume perspective, it'll be no different, right? It'll still keep the storage there until you delete the namespace or until you delete the persistent volume. So those are there. Let's write some data quick. Some data. And then let's take a look at what we have here though. So if we look at our pods now, right? The first thing we notice, which is actually incredibly convenient for actually executing into containers, but we have a different name here, right? It's called just worker 0. That's it. But let's go in there and take a look for a second, just to see that everything else is in fact the same. All right, so you got some data there, same path. And now let's do this for a second. I want to restart this. So this is going to look similar to the deployment command, but it'll have a different type there. So if you do rollout restart again, we'll do a stateful set instead of deploy and restart the worker. So it's like, yep, I'll do that. Great, no big deal. A little different though, and this is some of the behavior that the deployment doesn't do. Catch this in time. No, let's do it one more time, just to show that a little differently. So if we look at that, right, unlike the deployment, which did a rolling deployment, one stayed up while the new one came up. Here, it entirely terminates that pod first. And so one of the disadvantages with using stateful sets is that you don't get full rolling deployments. So you can't, if you only have one and you restart it, it's going to entirely take one down. You don't have one still up. And that's one of the reasons it handles the persistent volumes better, right? Because it doesn't try to keep the same PVC bound to more than one instance, even though it worked perfectly fine in Minikube. And so now that that's back up, we'll just go back in just to, name hasn't changed, right? Still worker 0. And then we'll just do all right. So storage, early storage, right? We still have data there, all worker 0. And so those are really, some of the differences between the stateful set and the deployment. The stateful set really is for stateful workloads. And that's not necessarily the biggest deal when you're just storing data. But if you consider things like Cassandra or Redis that really do want to choose a leader that want to, that essentially need a reliable host name, that becomes really important for those types of workloads. And so that's sort of, the handling of this from the Kubernetes side. Right, from the application side, what does this mean, right? How does this impact what you decide? And so let me actually do one more thing here, just because I can. And then I'll go over one more thing. So let's replicate this, right? Add 2 of them here. Worker. But so if we look at this, right, now that we've just scaled this out, we now have 2 PVCs, right? So again, that's handling it correctly. The whole charade with the deployment sharing the same thing, that's not real life. It's just not. It'd be great, but it's not. But so for every time you scale out a stateful set and you make a new replica of it, you do end up with a different PVC for it, with a different volume essentially. And so now if we do this, right, let's just run this. We do that. And so now let's just do this like 1,000,000 times or so. And let's go back into here and let's go to lib/storage. And let's just see, we have a worker 0. So right, all the requests I made, none got to this volume, right? This volume is for worker 0. And if we flip back here, we look at worker 1. None made it there. None are making this one. Had some made it into this though. You would see all worker 1 here. And so you have a replicated service, right, with literal different storage locations. All right, so now that's what I was saying about implications for the application. So one of them is that it is without having something with either 2 containers in the same pod or something that handles read write many, like Gluster, Ceph, maybe a handful of others that tend to add a fair bit of complexity. It's nearly impossible to have 2 containers in 2 different pods writing to the same literal storage location, which means that if you really do need to store something on a file system, maybe you store images, maybe you have some shopping cart data there, you really need to handle a sharded case where you are going to have to say, all right, every container that's running in that has, I need you to all give me your data for me to get a complete view of it. And that becomes horribly problematic, both from an application side, but also from sort of a plumbing side to have that ability in Kubernetes. And the other part, and I mentioned this earlier on, right? The other part is performance. Most cloud providers have really good SSDs. They have really good throughput. I haven't hit the issue, but it is possible. But really, when I've come across it, right, all the questions that I've had about why can't we just use a file system that's shared? That becomes one of the biggest, I don't say misunderstandings, but points of interest, we'll say, about why as a developer, you really do need to be aware that Kubernetes is different if you're running there versus what you're doing locally. Right, both in perspective of being able to share the files, but also having to collect back all the files that are in different volumes. And so let's see, I think that is about where I wanted to end today. Now we have a little bit of time left, and I probably a little after this. Is there anything about this that either I haven't covered or that you've run across and you have questions on that we should go over at all?
First of all, amazing presentation. And I don't say this to every single speaker we have, just so you know. I just want to know is that in your learning journey, and also you've seen the development of Kubernetes since 2015, so almost 7 years at this point. What has been challenging for you, and based on that, for other folks that are in our community, what are the challenges that they should anticipate? We do have resources such as your book. But I'm just saying, as a practitioner, speaking to other practitioners, what are the things that, when you got started, be like, would have been really helpful if I had known this, or I really wish I had taken a look at that? What kind of advice would you give in that sense?
So there are a couple of things, right? One is storage, right? I had no idea how storage got handled in Kubernetes or really in any other clustered system. It turns out it's hard. Over the years, I've come to believe that storage is the hardest part of any distributed system, because nothing handles it. It's always on you to figure out the best ways to do it. And that just comes from sort of, as you saw today, as I saw today, the other part of this is things change extraordinarily quickly. Something I didn't cover here, it was sort of, it sounds relevant, but not super relevant, is this thing called container attached storage, right? It's sort of a new way to explore how can you really handle state in Kubernetes, but from the storage perspective, not from, it wouldn't change your mind as an application developer. It wouldn't change your mind necessarily on the fact that you can put certain workloads in Kubernetes, but it's how you build the services that need to handle state, right? That's what gets tossed there. Things change quickly. From the behavior of Minikube to MicroK to the different types of CSI drivers you have, it's a very quick system to keep up with. And so really, if you're going to be an application developer, really, or a Kubernetes admin, but I'm sort of talking more from the developer perspective, and your services are going to be deployed to a cluster, it's easy to ignore that fact, but it's really not going to be in your best interests, right? You're going to want to follow along with it. You're going to want to know the capabilities of it, or it's going to end up coming back and you're going to have an issue in the end. And so that's part of it. And the other is just this is more too early on. Like, there were fewer primitives, there were fewer things that occurred, but just the amount of resources that Kubernetes has, and I don't mean like the books, I mean like actual, like their descriptions of things like a deployment or a stateful set or ingress, like those types of resources. It's a hard word to use in this context, but there's just so many of them that it really does take time to get your head around. So the other piece of advice here, right, is if, let's say your company is not using Kubernetes, don't suggest it. That sounds counterintuitive until you do get a handle on it, though. I think it's my favorite thing to do. Like, I really do love running workloads in Kubernetes. Don't try to go down that path until you've had some experience with it. You'll miss something.
That's really sound advice, because there is so much. It's no exaggeration that there's a lot of hype behind Kubernetes, and so that people might feel the pressure just to run into it. But like you said, do yourself a favor of getting that hands-on experience before you make that jump and perhaps run into problems. And I think it's interesting that you mentioned, we talk a lot about stakeholders, and we talk a lot about roles and responsibilities, what's in your toolkit, and that for a developer that previously they may have thought, oh, the scope of my work is limited to this area. Well, in the Kubernetes environment, particularly in the data on Kubernetes environment, you say, well, actually, now you do need to start considering things like storage. I think that's a good insight for people to be aware of the landscape that they can plan on encountering. Any other advice?
I think that's all I got so far.
No, that's good. Don't worry, that's plenty. Yeah.
for this. Except if you do have questions, I think you mentioned I'm in Slack. Feel free to ping me. We can have more discussions about this or other areas that I've missed or that you're curious about.
Yeah, we do have, we got a question on YouTube. Are you able to share the code that you used?
Oh yeah, sorry, I meant to share that. I'll put it in the Slack, but it's actually publicly on GitHub.
Okay.
Just I touched about it, and I will share the slides too.
Okay, perfect.
Ahead of time.
Perfect. Yeah.
I'll toss a link in Slack.
Okay.
It's on my public GitHub. You can totally get to it now.
Very, very good. That's awesome. Rob, this was an excellent live stream, one that I wish that we had some months ago, because it very practically laid things out as you did in the slides, and then taking it away with the demo. We do have a tradition in our community before we finish up. And just a reminder, folks, we still got a live project to give away. So you can expect to see a question in our Slack about something that we touched on in the live stream. So if you want to win that, jump in our Slack once this is over. Keep your eyes open. We'll be dropping the question in there today, so you can get that. Just to reiterate as well, further up in the YouTube chat, you've got that link to go to Manning. You can get a 35% discount on all of their products in all formats. So definitely take advantage of that while it's still available. But like I said, before we finish up, while we've been talking, as a tradition in our community, we have our wonderful artist, Angel, who's been drawing an artistic depiction of some of the things that Rob covered. So you can see that here of some of the things that were mentioned in the live stream in a more creative format. So we can take that away with us as well too. Rob, this has been super good. What's the best way? Obviously, we're going to be keeping the conversation going on Slack. If people want to follow you, is best to do it Twitter, LinkedIn, GitHub? What's the best way?
All right. So I look really villainous there, man. I look evil. Not that I'm saying that's not true. I'm not making that claim at all, but just an observation there. LinkedIn is good. GitHub is good. I am a complete slacker on Twitter. I should probably get better at that. I guess I can use this as an opportunity to be reminded of that.
It's all good, but everybody has their preferences. It's no big deal.
I'm an entire social media slacker. True story.
I would say that's actually a really good quality to have in 2022 when we're being bombarded. Yeah, folks, if you haven't seen the documentary, The Social Dilemma on Netflix, you should definitely check it out to make you have a better idea about how to use social media the right way, and don't let social media use you. So anyway, but I think that's, we got in contact, I believe, through LinkedIn. So anyway, the LinkedIn is a good way to get in touch with Rob. Also in our Slack, we'll be continuing the conversation there. I would love to have you as a speaker in KubeCon, Rob. So keep May 16th open on your agenda. Okay. And we'll get the CFP to you, because this is great stuff that we had here today, and I'd like to take it further. And particularly as well too, it's always refreshing to have someone like yourself working at a great company like Rumble, who's talking about it, from that perspective, really, practitioner hands-on. So very, very nice to have you with us today. Folks, as usual, we're always continuing the conversation in Slack. We got a live stream tomorrow for newer folks about how to use Helm properly. You can never get too much information about these building blocks. So if you want to join us for that tomorrow, we'll be here at the regular time. Rob, thank you very much. We will talk to you soon.
All right. Thank